So let's work an example. Suppose we have a car, probably a small model car, that travels along the path shown. So it goes from 1 meter to 9 meters and turns around and comes back to 6 meters. We would like to find the car's displacement, the distance it travels, the car's average velocity, and the car's average speed. Well, I need a little more space. So I'm going to take this and shrink it a little bit. And we'll just put it up here in the corner for the moment. The first thing we want to find is the displacement. Well, displacement is nothing more than the final position minus the initial position. That is delta x, which is equal to 6 meters, that's the final position, minus 1 meter, that's the initial position, and that is 5 meters. And it's positive. All right, so I'm going to box that as I box all my answers. I'm going to take my select tool. Oops. I'm going to group this. Group. I'm going to shrink this and place it over there. Now we'd like to find the distance. Well, the distance comes from two different steps. First we go from 1 meter to 9 meters. So that gives me 9 meters minus 1 meter. That'll be one of my steps. But in the next step, I go from 9 meters back to 6 meters. So I'll take 9 meters minus 6 meters. Notice that I didn't take final minus initial this time because it's in the negative direction and I want the actual distance traveled. So here I'm taking an absolute value. I'm finding the total distance that he travels. So this gives me 8 meters plus 3 meters. You'll notice that if I had done final minus initial here, this would have been negative 3 meters, and this would have added together to give me the displacement. But because I'm doing distance, I'm taking everything to be positive. Oops. And this will be 11 meters. And we'll put this to the side. All right, the next thing we want to consider is average velocity. Average velocity is displacement over time. So V average is 5 meters divided by 5 seconds, and that'll give me 1.0 meters per second. By contrast, if I want to deal with average speed is distance over time. So that would be 11 meters divided by 5 seconds, giving me 2.2 meters per second. All right. So there are our answers. The displacement is 5 meters, but the total distance traveled is 11 meters. The average velocity is 1 meter per second, and the average speed is 2.2 meters per second. And we can see a glimpse here of what needs to happen for the average velocity and the average speed to be the same, or for the displacement and the distance to be the same. Here, distance was more than displacement because I turned around and came backwards. So if the entire motion is all in one direction, the displacement and the distance will be the same. But if you change direction, either by turning in more than one dimension or by turning around and coming back, the distance will always be longer than the displacement.